Okay, welcome everyone. It's 2 o'clock, and I think whilst people are still joining us, we may as well get started. Welcome to this network meeting of TAPAS, Tackling Air Pollution at School. My name is Paul Linden, and I'm the principal investigator on the TAPAS project. And we have a very, I think, full and interesting afternoon ahead of us. We're going to address the question about whether air cleaners should be used in schools. And we have a lineup of interesting speakers to discuss this topic, along with a couple of breakout sessions to discuss it as well. So I'd like to welcome you all to that. Just to say a word or two about TAPAS. TAPAS is one of the clean air strategic priority funded projects sponsored by the National Environmental Research Council of the UK. And the object behind TAPAS is to develop a community to some extent around the question about air quality in schools. Of course, we've been strongly influenced by COVID, both in terms of how we operate within TAPAS, but also some of our perspectives, I think, about what air quality means have been altered as a result of that too. So I'm not going to take up much time. You can read about the network and get involved by looking at our website, and we'll put the web address in the chat at some point during the afternoon. But just to say again, welcome to everyone. For the speakers, we have a rather tight program, so I'm going to ask the speakers please to try and keep to time. I will indicate when you've got about 3 minutes to go. Would you, the audience, please put questions for the speakers in the chat, and I will deal with them at the end of each of the talks. I think the other thing to say is that we are recording this afternoon's activities. And so if you do not wish to be recorded, please keep your camera off and don't speak. But otherwise, you'll be being recorded for posterity. Okay, so I think that's all I really want to say at this point. Other than now to start by introducing our first speaker, who's Professor Nicola Carslaw. Nick is a specialist in indoor air quality and has worked in this area for a considerable time. She's at the University of York, and she's going to talk about issues associated with standardization of air cleaners. And I'm going to hand straight over to you, Nick, if you want to share your screen.
Okay, so very unprofessionally started at the end.
It seems to work.
Good stuff. Okay, so I've actually changed my title slightly, because I think what I really wanted to talk about was just to give a bit of an introduction to some of the things that are going to come up today. So I couldn't really talk about how air cleaners are being regulated at the moment and standards, because there aren't any. So what I thought I would start to talk about is some of the issues and maybe the first steps towards regulation. What are the sorts of things that we need to consider? So I'll very briefly talk about sources of indoor air pollution. I suspect most people on the call will be very aware of those. And just briefly talk about why air cleaners are being used in schools. And obviously that's the question that we want to address today. Do we need to use air cleaners in schools? And if we do, under what conditions? And then a little bit on the types of air cleaners that are available and the issues with some of those, and then some summarizing remarks. So this slide just shows a range of typical sources of pollution indoors, and some of the things certainly that we study at York. So we're interested in things like cooking emissions, the emissions you get from using cleaning products, burning scented candles, using air fresheners, and also just the presence of people in indoor spaces. So we know that people breathe in and out, and this is relevant for schools. We're going to talk a lot about CO2 later, for instance. But also we know that there are reactions that go on the surface of the skin. So we know that if ozone comes into a space, it can react with the components of your skin oil and produce lots of things like carbonyl compounds. So if you have a unventilated area or a poorly ventilated area, particularly if it's highly occupied, you can start to see the effects of some of these emissions. And then we also know that there are fragrances and things like that indoors as well. So obviously, when you come to the school environment, some of these sources will be relevant. So schools are cleaned. Depending on their age, school children would be wearing fragrances. So having 2 teenage sons, I know all about the Lynx effect. But also there will be other activities going on at school that will lead to indoor emissions. And just things like, there's some really nice work done in Spain by Javier Querol and his co-workers looking at things like even the surface of the playground can have an effect, because if it's a sandy component, you can end up with children bringing in some of those particles on their feet when they come in after playtime. So there's all sorts of considerations for schools as well, but these are just some general sources. And we obviously care about the air quality in schools because we know that if it's not very good, it can affect performance. So I've just pulled this slide off from online, and there could be any number of these sorts of demonstrations. But we know that, for instance, if CO2 concentrations are too high, it can affect performance. And again, we will be going back to CO2 later. But just to say that although we tend to focus on CO2 as a proxy for indoor air quality, if there are high CO2 levels indoors, it's likely that there are other high concentrations as well. And some of those are likely to be more or cause more adverse health effects than CO2 itself. And then if we look back on the last 2 years, a lot of the focus on air cleaning in schools has been around COVID, not surprisingly. And a lot of the air cleaners that are being used, the focus is on removing COVID from the air that is breathed in schools, not surprisingly. But I guess more widely, before COVID and presumably after COVID as well, we're still going to be focusing on the role of air cleaners in terms of removing pollutants from air, so things like PM particularly. And sometimes schools have a real battle on their hands. So, you know, they need to keep the air quality in their classrooms to a good level, because we've just seen that it will affect the performance of the children. But it's not always possible to open windows without being subject to things like this with cars and traffic emissions. So then this is the sort of thing that would force schools down the road of needing to think about air cleaning technology. So if you go onto something like Google and you search indoor air cleaners, you get a whole range of these different products. They range in price, in size, in mode of operation. And you can imagine that if you have no experience or no understanding, or even if you do have a bit of technological experience, it'll be really hard to understand which of these is right for your space, whether it's a school or any other space, in fact. And what really bugs me with some of these is where they call themselves air purifiers as well. So air cleaning is debatable, but air purifiers is definitely very, very debatable. And I actually went along to IUPAC, which is kind of one of the standards for thinking about air quality. And you can see that the definition of air purification or pure air is that air is considered to be free of aerosols and reactive gaseous contaminants of anthropogenic origin. And I don't think many of these air cleaners could claim to be removing all of those things through their operation. So SAGE in November 2020, in response to the COVID pandemic, the environmental modelling group of SAGE wrote this report for government where they looked at the potential application of air cleaning devices. And that was obviously focused on removing COVID rather than air quality. I just wanted to quickly run through some of the key conclusions from this report. So I apologise, this is a little text heavy, but these are the important conclusions, I think. So the first conclusion was that you probably don't need an air cleaning device if your space is already adequately ventilated. Okay, so that's an important thing to determine whether it's a school or any other building, is what is the level of ventilation? Is that adequate? Do you actually need an air cleaner? And then the types of cleaners that SAGE actually recommended, if you did have to then put in a layer of air cleaning based on inadequate ventilation, was that should be restricted to this fibrous filtration. So we're talking about your HEPA filters or germicidal irradiation by UV. And then you can see that there's some sub comments here that they are beneficial if deployed correctly. So that's important. And we go back to, about ventilation. So I suppose the first step would be, can you improve ventilation first? But then this extra step that ideally you'd want their efficacy and safety to actually be evidenced by relevant test data and testing, which doesn't really happen at the moment, apart from by the manufacturer. And then you can see the recommendation around these other technologies, ionizers, plasma, chemical oxidation, photocatalytic oxidation, etc., is that there's limited evidence that they work for COVID, but also quite a lot of evidence that some of these technologies produce secondary pollutants that may be more harmful to health. And even though the SAGE report was focused on COVID, many of the conclusions are relevant for air quality. So these technologies will still be making those same secondary pollutants when they're operated. So just for an example of that, this is just part of a table taken out of the SAGE report. So you can see there's different methods here. So we've got catalytic oxidation at the top, plasma, precipitation, electrostatic precipitation. So this column here, I mean, don't worry about too much about the detail. This column here is how effective it was against SARS-CoV-2. But the column on the right, which is what I want to draw your attention to, is what some of these byproducts are that are being produced. So you can see catalytic oxidation can produce some of these aldehydes like formaldehyde. We know formaldehyde can be carcinogenic, can produce ozone, respiratory irritant, also possibly producing nitrogen dioxide. And then if we go down to the plasma, you see you've got similar problems. You can make NOx and ozone, and the same with electrostatic precipitation. So you have to be really careful if you're putting these devices into a classroom or any other building, in fact, that you're not actually making the problem worse. You may remove PM with some of these technologies, but you may make in the process things like formaldehyde and ozone. So, oops. I actually stole this from Ed Wieland at Cundall. So he came to give a talk to one of our TAPAS subgroups last week, and I thought it was a really nice illustration. So he calls this a hierarchy of risk. And basically what you have at the top is the kind of lowest risk air cleaning technology, if you like. So that's shown in green. And we go down to the riskier technologies at the bottom in orange and red. So you can see you've got the oxidation techniques, plasma, and anything that generates ozone at the bottom here. So at the moment, the only guidance that schools could use really is the information that is provided by manufacturers about their different technologies. So basically what we think you need, and that's people working in the TAPAS group, is that there needs to be more burden of proof on the manufacturer to demonstrate the safety of their technologies, and that this needs to be done in a realistic environment. So if you took one of these instruments and used it in a controlled chamber, and you had very nice constant temperature and humidity, and you didn't have any air pollutants around, such as might come in through a window in a school, it's not going to be a realistic test of that instrument. So it needs to be tested in a realistic environment where you have things like changing temperature and humidity, and you have other pollutants floating around as well. And that needs to be thought through. So we need to think about, are these technologies making other pollutants during operation? Are they easy to maintain? And what happens over time? How often do schools need to intervene in these technologies to change filters or change other components, for instance? And this really needs to be thought through holistically. You need to think about biological safety, but also chemical safety. So typically, again, the manufacturers of these instruments might look at one aspect. So they might look at how their technology removes COVID or how it removes PM, but perhaps not thinking about how in doing so it can make other chemicals. So there really needs to be a holistic approach to testing these things. So I think I just have one more slide. There we go. So I think these are issues that I just wanted to put down here to maybe to help initiate thought for some of the discussions later. So I think the first question is, is an air cleaning device even needed in a building, and particularly in schools, as we're focusing on today? Can ventilation be improved instead? And I guess the other thing is, by using air cleaning, aren't we just avoiding the elephant in the room? Or in other words, are we just not doing what we should be doing, which is cleaning up our outdoor air? So if the roads outside schools weren't full of traffic, then they could open the windows and we wouldn't have to worry about air cleaning anyway. So it's not really dealing with the source of the problem. And then some things to think about: how suitable are the air cleaners for classrooms? So there's issues around noise, and this is something that Ed was talking about last week as well, that if you have a noisy air cleaner, what tends to happen is you end up turning it down, so it's less effective, so it may not be as much use as you thought it would be anyway. What's the clean air delivery rate? Is that actually sufficient for the space that you want to keep clean? What are the maintenance costs, and what is the financial cost? And then when it comes to which device to choose, if you have to choose an air cleaning device, at the moment, there's no regulation for these things at all. And we really think that regulation needs to be brought in. And that will really help schools who, you know, there's lots of, or we've heard anecdotally, there's evidence that schools are being approached to buy these air cleaners, but there's nowhere really for them to go to understand if that technology is suitable or safe. And that really needs to exist, we think. So tests need to be carried out in controlled, realistic environments. Sorry, that should say in realistic, non-controlled environments. I've got a bit confused there, but basically tests need to be carried out in realistic indoor environments, not under those lab conditions I've been talking about. And then I guess just to highlight the last point here, many manufacturers aren't probably even aware that some of their technologies might be making secondary pollutants. So this is the well-known streetlight effect, where you have the police officer coming up to the guy looking for his keys under the streetlight. And when asked why he's looking there for his keys, he tells the policeman because that's the part that's lit. So it's thinking about, you know, the things that you're not looking for as well. So I think with that, at 13 and a half minutes, I believe I will end, and happy to take any questions if there are any.
Thank you. Thank you very much, Nick. I don't see any questions in the chat. Does anybody want to raise a question? If they do directly, they could just unmute themselves and ask a question.
Can I jump in with one, please?
Yes, sure.
Hi there. Thanks for the presentation, Nick. I totally echo most of the points that you put across. We've been working in the clean air field for about 7 years now before it became fashionable and all these box shifters jumped on the scene to try and sell things out of the ordinary. We do a lot of work with BESA, the Building Engineering Services Association, and we're pushing forward for regulation change and speaking with members of SAGE and CIBSE. Unfortunately, we're hearing that this is many, many years away. So I'm just wondering if you're aware of any guidance now that teachers and representatives can access to gain an insight into the basics of air cleaners.
Well, there is a SAGE report. We've been talking within TAPAS about whether we can come up with something that's a bit more digestible. And also with Global Action Plan that are part of TAPAS, they're looking at talking to schools and to at least come up with a basic checklist. But it's disappointing if regulation is not going to be along for several years. I think this is something that needs to be done a lot sooner than that. So nothing that I'm aware of, but we have got Paul Monks coming later. He might not be on the call yet, but he's Chief Scientific Officer at BEIS, and maybe that's something we could ask him.
Yeah, thank you very much. I think it's a very good point that you raised, Nathan. Thank you. We should move on now. Thank you very much, Nick. It was a very good way of setting the scene for this afternoon.